This time our object is going to be at 3.5 centimeters, 35 centimeters for me. It's still the same object in terms of height. So here's our object. Okay. All right, the second example that I want to do is an object that's moved in a bit closer. Now it's falling in the range between twice the focal length and the focal length. And let's find out where that image is. Still going to be the same lens, still going to be the same object in terms of the object height. So, the first ray I draw is a ray traveling parallel to the principal axis. And of course, it's going to intersect the lens at exactly the same height. So I mark that location so that I know that I have a nice parallel line. Any light rays that are traveling parallel to the principal axis are going to be refracted towards the focal length. All right? So this is, again, the exact same ray that we had in the first case. We haven't changed the lens, and we haven't changed the height of the object, so this ray is going to be look pretty much the same. The second ray I draw is a ray that is coming from the tip of the object and goes through the focal point on this side. I'm going to have to refigure what that is. 25 right there. So a ray coming from the object and going through the focal point on this side. Right? Now that's hitting my principal plane way down here, beyond what I've shown the lens to be. It doesn't matter in terms of the ray trace. So that ray is going to be refracted parallel to the principal plane. Whoa. We might go off our paper here. I think I just got lucky. So we can see that these two rays are going to converge way down here. I'm going to draw in my object. Of my image, drawing my image. So now my image is down here. And you can kind of see that as you get closer to the focal length, this ray is going to go, going to keep bending further down. It's going to intersect. Your object is going to get, your magnification is going to be pretty big. We can see that we have an inverted real image that is magnified. I forgot to write, in this case up here, we have a real inverted image that is reduced in size. Over here, it's a reduction in the image size. In this space, it's a magnification of the image size. And at this point right here, it's neither magnified or reduced. This was the special case that we covered in the previous lesson. So when we're farther than the focal length, it's going to be when we're farther than when we are farther than twice the focal length away, we have a reduced image, real and inverted. When we are at twice the focal length, it's a magnification of 1. And when we are between the focal length and twice the focal length, we have a magnified image. Now the third and final case we're going to look at is when we have an object located inside the focal length.